Welcome to the Lesson 16 demo for Math 107. You'll know that there's no preview exercise for this lesson. So today we're briefly going to review equations of lines and learn how to create linear models using linear regression for real-world data. So in 1995, there were 246,855 alternative fueled vehicles in the United States, and in 1997, there were 280,205. If we measure time in years since 1995, translate the given information into two ordered pairs. So years since 1995, then 1995 is 0, and the number of alternative fueled vehicles is 246,855. And then my other point corresponds to this information. That's 2 years after 1995, 280,205 AFVs. To find the slope of the line passing through those two ordered pairs, your slope is your change in y over your change in x. So I'm going to subtract the y's, 280,205 minus 246,855 over 2 minus 0. $280,205 minus 246,855 divided by 2 is 11,675. If I want to interpret the slope as a rate of change, I need to include units for both variables. So this is really over 1. And y was representing number of AFVs, so AFVs per 1. X was representing years, right? So the slope can be interpreted as the number of AFVs is increasing by 11,675 each year. Okay, explain the significance of the Y-intercept in the context of this story. Be sure to explain both coordinates of the Y-intercept and give the units of both variables. Okay, well, first we need to find the Y-intercept. The Y-intercept, for any graph, the Y-intercept is is the place where the graph crosses the Y-axis. And in our case, the Y-axis is 1995, right? It's when X is 0. So my Y-intercept is 0, comma, 0 representing 1995, 0, comma, 246,855. So that point represents that in 1995, 0 years after 1995, there were 246,855 AFVs. Use your slope-intercept equation to predict the year when there will be 510,000 AFVs. So my slope-intercept equation is y equals mx plus b. And I now know my m and I know my b, right? So I have y equals, my b was 11,675 plus b, which is 246,855. And I want to know when there will be 510,000 AFVs. So which is AFVs, X or Y? It's Y. So I'm going to go ahead and replace the Y with 510,000 equals 11,675X plus 246,855 and solve for X. So I'm going to start by subtracting 246,000 minus 246,855 and then dividing by 11,675, and I get X is approximately 22.54 years. And remember, that is representing years after 1995. So if I want to estimate the number of AFVs on the road in 2003, I have to figure out how many years after 1995 that is. So I do 2003 minus 1995. That's 8 years after 1995. So I'm going to do y equals 11,675 times 8 plus 246,855 equals 340,255 AFVs in 2003. The actual number of AFVs on the road in 2003 was 510,805. Is the estimate we found based on the 2 points an underestimate or an overestimate? It's way under, right? We only predicted 340,000, so under. It's an underestimate. Okay, so let's assume that the number of AFVs in the US increased by precisely 16,675 vehicles each year. The scatter plot of the data would look like this. So I've got a bunch of points. All my data is over here. And the equation of the line we found earlier, 16,000, that's 11,000, 11,675 plus 246,855 would pass through every data point exactly linear as shown below. So we would call this perfect correlation. Usually when you're modeling real-world variables, we get data and a scatter plot more like this graph. In this case, the data don't all fall on the same line. It's not exactly linear. However, the data do seem to all fall near the same line, even if the correlation is perfect. Don't fret, even though the data are not exactly linear, we can still find an approximate linear model for the data. So here's the real world data with a line drawn through the 2 data points that we were given in 1A of the demo. So here's 0, 246,855 and 2, 280,205. So now you choose any other 2 points from the data and draw a line through them. So like if I pick this point E and this point G and draw a line through them, it's a very different line than the line through the first 2 data points. If everyone in the class put all of our lines on the same graph, you'd have a 28 different lines, right? So how do we decide which line is the best fit for all the data? So this semester, we're going to just let a calculator or computer decide. If you take a statistics or calculus course, you'll be able to do this yourself. But for now, we're just going to let technology do that. The equation of the best fit line or regression line for this data is 35,443 x plus 216,437. So the way you get that is not super important. You will not ever be asked to perform the regression steps on technology on a quiz or a test, but you will need to be able to interpret it, right? If I give you this picture and this equation, I can ask you some questions about those things. So other than just looking at the scatter plot and seeing that a line seems like a good model, we do have a way to quantify the strength of a linear trend. So a number called the correlation coefficient, which we denote R, it tells you the strength and the direction of the relationship. So it's always a number between -1 and 1. The closer to either endpoint, the stronger the relationship. The closer to 0, the weaker the relationship. And when it's positive, then you have a line that's increasing, and when it's negative, you have a line that's decreasing, like these pictures. Very important to remember that strong correlation does not necessarily mean that X causes Y, or that Y causes X.